Ni hao. That's all the Chinese you're going to get. I'm really happy to be here. The Global Acceptance Network, or GAN for short, just went public via LinkedIn primarily. It's a very soft launch last month. So this is only the second talk I've given publicly about it. And I'll try and paint the whole picture of why we're introducing this new global digital public utility. Yesterday, I was part of the W3C DID Forum workshop, and that's because I spent 7 years of the 30 years I've worked on decentralized identity, developing the DID, Decentralized Identifier Specification. 5 years before it went to W3C, and then 2 years in the working group process there. And finally it was approved 2 years ago. And I was thrilled yesterday to see how vibrant the DID community is here in China. And what we're going to talk about here today is going to build on top of where we're going with DIDs. The other thing is, a number of you may be familiar with me through this book, published by Manning 2021. And there's one translation that has been done, and the translator's right here with us today. So I have a Chinese edition, which, by the way, I brought these two. I'm happy to pass them on to some deserving person or group here. Manning, by the way, is asking for a second edition of the book, and I've told him, myself and the other authors, we're all so busy in this space, I'm not sure when we'll be able to get to it. But, you know, maybe there will be another edition here soon. So, as I said yesterday, we were talking about DIDs as what I call the atomic building block of decentralized digital trust infrastructure. That's the basic structure of a DID, and as I covered yesterday, there are now more than 198 DID methods that have been developed, or excuse me, registered with W3C. There are more methods beyond that. We're now moving potentially into a stage of starting to standardize DID methods, including the potential of a new working group at W3C on that topic. And then you just heard from Wenjing, who I work very closely with at Trust Over IP Foundation and Open Wallet Foundation, on the basic rationale for the trust spanning protocol, being able to connect any two DID identified endpoints or anything, right? Even though self-sovereign identity is often associated with people, it applies to organizations, it applies to devices, AI bots, anything for which you need identity. And that means the trust spanning protocol can establish cryptographic trust between any of those two endpoints. So what I want to talk about here today is how we can actually build what's long been called the trust layer for the internet. And I've been in other conferences, including some major blockchain presentations, where the promise is, we're going to deliver the trust layer for the internet. And in the back of my mind, that whole time, I'm like, you're way underestimating what really it's going to be required to deliver that. And I'm going to explain here today what I think it really does require and why we finally can deliver it for real. But it's still going to be a lot of work in front of us. I would suggest very much the kind of work that it took to initially establish the internet once we had the protocols, or to build out the World Wide Web once we had the protocols. So I'm going to start with the the trust over IP stack. You just heard from Wenjing. He and I are two of the founding steering members of the Trust over IP Foundation. It is a Linux Foundation project started 4.5 years ago. We are a sister project of C2PA, of the Decentralized Identity Foundation, and other projects, which are now, a number of us are consolidating under LF Decentralized Trust. This was just announced earlier this summer, and they just had the launch. Wenjing was there in Vienna last month. So we have the LF Decentralized Trust Member Summit in San Francisco next week, which is why Wenjing and I have to go right back over there. So Trust over IP, again, 4.5 years ago, a group of us that had been working on different aspects of decentralized identity and trust said, okay, we believe we really have a clear picture of what it will require to deliver this trust layer. And we said we talked to some existing foundations, but we said no one has made this their explicit mission. We should start a new Linux Foundation project to do that. Our inspiration was very clear right from the start. In fact, it's where the term trust over IP came from. And it was the hourglass model of the internet, as Wenjing referred to in his presentation. And to be specific, that hourglass model consists of 4 layers, and this is what it looks like for the internet today. The bottom layer is always the supporting protocols you need in an hourglass. It's whatever protocols are needed to support everything that's up above. The secret to the hourglass model is the next layer, a single spanning layer. This is what gives you interoperability between the supporting protocols and the supported protocols above that. You can see most of, not all, but most of the popular protocols used in the internet stack on that diagram. And that, of course, then supports the application layer, and you can see a number of examples up there. Again, the key to the hourglass model, and if you're interested, the original paper produced on the hourglass model, I highly recommend it. It's really good. It explains the rationale for why the spanning layer and why the spanning layer needs to be one single protocol that will enable the interoperability between the supporting protocols and everything above that. That's why you can use a phone on a 3G or 4G or 5G network and communicate seamlessly with a computer on a completely different network using a completely different application, right? Packets all move between. And one of the secrets of spanning protocols is generally addressing. IP spanning layer is best known for the IP address that made a device addressable anywhere on the internet. So the whole idea behind trust over IP was to say, we need to do the same thing for digital trust. We don't need to rebuild the internet. We can use the internet and its protocols down at the trust support layer. But what we will need is a trust spanning layer. And that is the trust spanning protocol that you just heard about from Wenjing. We call the layer above that the supported protocols trust tasks. It means that you don't need to use the trust over IP stack for everything, for all your communications. If you don't need trust in a particular communication, you don't need to use the stack. Just the way if you're doing something local on your computer, you don't need to talk to the internet. But when you have to talk to the internet, you call the TCP/IP stack. When you need to do a trusted operation, you'd call the trust over IP stack. And you will end up using the trust spanning protocol. But what will happen is the application you're using will call one or more trust task protocols, just the way you're going to call HTTP for a web interaction, or you're going to call SMTP for an email interaction. We believe there will be a lot more trust task protocols because they will be smaller and lighter and tuned to the kind of trust task you need to do. So, as you saw in Wenjing's presentation, this is a bigger picture of what we call our third generation picture of the stack. I see a lot of phones coming up, and that's great, but I guarantee you, if you want the really high resolution, you can get it right on the Trust Over IP website. Just go to the Our Model section. And it will actually run you through basically an interactive set of diagrams that build up to the full model. And I think it will help explain it. As you can see, we talk about the 4 layers: trust support, spanning, trust task, and application. But one of the most important things, also part of the original vision, is that technology alone is not enough to build and sustain trust. You must combine it with governance. Machines alone cannot make a decision for a human about a trust relationship. So that's why we've always called it a dual stack. You have your technology, your set of protocols, the things machines can process, but you tie it into governance. And what we show there in our third generation is that governance, it applies at each of these layers. You have things you'll need to govern, and I'll talk more of, especially about layer 1. But it needs to be also holistic so that all of the issues, all of the trust vulnerabilities that you need to tackle in a particular context can be addressed, the risk can be assessed, and then the governance that you need and the governed parties that need to be part of that, including, if necessary, certification or audit, all of that can be designed into your governance framework for what we call a digital trust ecosystem, which I'll cover in a minute. So this is why you have this dual stack, and governance is built into everything that is necessary to support trust on the internet. Now, I made this same point yesterday. The trust spanning layer that Wenjing talked about earlier can establish cryptographic trust, also called technical trust, between 2 endpoints. You can know that the identifier being used, whether it's a DID or any other form of what we call a verifiable identifier, cryptographically verifiable identifier, is being used on that other endpoint, and that you don't have a man in the middle or any of the types of attacks that would typically be there. But all you can establish at that layer is cryptographic trust. In order to move up to the layer of establishing human trust, who as a person, or whom as an organization, or what as an AI bot, as Wenjing's presentation covered, what are you dealing with on the other side? For that, you have to move up into the trust task layer, and most commonly into credential exchange. By that, we mean digitally verifiable credentials. I note that the term verifiable credential, when you use it in a W3C context, means very specifically one that conforms to the W3C verifiable credential data model. The term generically is used for any form of verifiable digital credential, including the ISO, MDL, or MDOC specs, the non-creds, AC/DC credentials. There's 5 or 6 different major formats. Any of those could be covered up at the trust task of either issuing or presenting or verifying revocation of a digital credential. Those are all classic examples of trust tasks. A lot of folks are so focused with digital wallets on credential exchange that they look at wallets narrowly and they don't think about value exchange or secure messaging or another requirement in the EU of the European Digital Identity Wallets Initiative, or the regulations technically called EIDAS 2. One of their requirements is that last thing on layer 3, digital signatures. A European digital identity wallet, part of being certified is you must be able to issue a digital signature from that wallet at what they call level of assurance high. So it will be legally acceptable, any form of a contract or financial transaction. They're setting a very high bar for what European digital identity wallets will need to be able to do. And if you're not familiar with the EIDAS 2 legislation, what's happening there, by the end of 2026, every European citizen has the right, not the obligation, they don't have to, but they will have the right to start using a digital wallet certified by their member state, any one of the 27 member states, and all of the businesses in the EU, and even the big tech providers, must accept that wallet. And they must accept the credential called the personal identity credential, a PID credential, in that wallet for proof of identity. So it's the largest digital identity wallet initiative that we're aware of in the world today. It's not the most advanced. I would actually say that's Bhutan. That's another story. But it's just, I'm sharing that, digital wallets, digital credentials, implementing at least portions of the stack, this is happening in the world today. And that's force that's driving us forward towards the next part of what I'll talk about. So, when you get to that credential layer, you enter what we call the province or problem space of digital trust ecosystems. And I'll try and be very specific. What is a digital trust ecosystem? First, I'll give you a moment to read this. Of course, it's in English. We'll see how good the translation is. This is the definition from the Trust over IP glossary. Besides the technical stack working group that I co-chair, for 4 years I have been one of the co-chairs of our concept and terminology working group. And when it comes to the issues involved with digital identity and digital trust, terminology is supremely important. I've been at conferences and email threads, hundreds of messages long, just talking about what is identity, right? So you have to be very precise about these terms. And by the way, we're very interested, besides just translating books, we're just reaching the point now where the Trust RP glossary, which has over 500 terms in it, is well suited for translation. And we would love to start partnering with others who would like to see it in other languages. We have actually built open source software to support it so that just for the open source folks in the room, every definition in there is a separate markdown file in GitHub. So you can version every definition, and we're going to tree it out just like Wikipedia so that the translations in different languages can all be covered or added to the same tree so that we can have a multilingual glossary to serve all of us and the applications we're developing in that area. So if you're interested, by the way, that is the definition of that is the URL for this term. I'm going to give you a much simpler way to look at what is the essence of a digital trust ecosystem. And this diagram, which the top half of which is broadly referred to as the trust triangle. And as Wenjing pointed out earlier, The trust triangle applies to every credential, physical or digital, of any kind, wherever it's produced. The whole point of digital credentials, I mean physical or digital credentials, is to transfer trust, to do transfer of trust. And it means that an issuer of that credential has a certain relationship, certain trust relationship with the holder that it's being issued to. And that enables that holder to then go to a verifier, often also called a relying party. That's a more federated identity term, and it got narrowed down to verifier when we're talking decentralized identity. And the verifier, this is a very important point, does not, in general, get a direct copy of the credential. They only need a proof. And that's one of the biggest privacy leaps with credentials, is those proofs can only reveal exactly what the verifier needs to know. Classic example is you could have a driver's license or a passport and only show a proof that you're over or under a certain age. So it is inherently a privacy-preserving technology, done right. There's some regulatory bodies that are, we're trying to continue to educate about that. So the bottom half, what turns the trust triangle into what we call the governance diamond, is whenever you need to scale a digital trust ecosystem, what you'll need is a governing body of some kind. And if you look at the definition of that term, it doesn't mean just a government. Any, what we call trust community of any size, any kind, a company, a group of companies, an association, a state, a city, a county, a region, church, a neighborhood, your family could be a digital trust ecosystem if there was some information that you needed to share. In order to reference the human readable part, I'm going to walk all the way over here and highlight this. This is a set of documents that document your policies for that ecosystem. And that, even though you can come up with a machine-readable version of it, what matters is the human-readable version. This is what humans will decide. You look at the laws of a country, well, it's what those laws say that allow you to make a decision. Do you trust that or not? So the most important thing in trust of RP architecture about governance frameworks is that they have a DID. They are cryptographically, verifiably identified. And all that is then necessary is when you're communicating in the context of that ecosystem, the credentials or the messages you're exchanging can include that DID. So you know what the applicable policies are. Now, the more of your governance framework is machine readable or even just machine referenceable, as in, let's say it's a very large, complex framework like EIDAS, if you could reference specific policies, again, with a DID URL, then you can be very specific about the context of any particular transaction, what policy applies. This helps all the way down the line. Imagine that there's a problem that comes up. Well, now the parties can not only reference, well, this happened, we can cryptographically prove what happened, but they can reference the exact policies that the parties were fully aware of, informed of. That's the key link between governance and the technology. All right, so I'm going to get a little bit more specific here about what really makes digital trust ecosystems work. And this version of it, you still have the same core roles there, but it highlights the heart of it is a credential family. Whatever ecosystem you're talking about, you know, if it's a work-related ecosystem, then it's an employee credential, or it's a right-to-work credential. If it's a health ecosystem, it's a health insurance credential, or it's a health record. If it's a financial ecosystem, it's a banking credential or an audit record. Whatever the ecosystem, whatever the trust task, there is an associated set of credentials or verifiable data that goes with it. And that's what the ecosystem is designed to enable. And again, all of those credentials, one way or another, that's what you're using to develop transitive trust. And the first job is to do it within that ecosystem, right? EIDAS, the governing body, is the European Commission. But they need to delegate that down. We'll cover that in a minute. They're not saying we govern everything. We govern the big picture. Member states then have governance within that, and they will delegate further down. But anyway, the heart of it all is going to be a credential family and the associated policies. So I want to add one more dimension to the understanding of the trust over IP stack. And this is the key sort of innovation in our third generation of this model, which is the dual stack that you saw here of technology and governance. It exists for one purpose, to provide an interoperability model for digital trust ecosystems. The ecosystems are instances of that stack. They're the ones that actually need to communicate and solve trust problems. And trust over IP has nothing to do with making any decisions or any policies for digital trust ecosystems. On the governance side, we have a governance stack working group. I was co-chair of that when we got it started for the first 2 years. We basically created tools for helping you develop the policies for a digital trust ecosystem. But we're not involved in any of your policies, right? That's up to your nation state, your industry, your company, your school, your neighborhood, your church. You're the one that decides your policies. As the way we put it is, people hear this term self-sovereign identity, everybody's sovereign, right? There's some countries that really didn't like that term when it first came out, and I understand why, but now I point out to them, wait a minute, you're sovereigns. You're the original sovereigns. We're all sovereigns. We can all benefit from self-sovereign identity. Okay. Now, as I said, ecosystems are the heroes of this whole design. Now, to just sort of set your expectations, once you start to look at internet scalable digital trust, we will have tens of thousands of these. Think a little bit like websites. Now, it's larger than websites. It's more like, entire domains. But the point is, there won't be just a couple. This isn't going to be a winner-take-all kind of game, right? Countries will always be sovereign for what they're doing, and they will delegate within the country and arrange their own ecosystems. Industries will do the same thing, right? It's going to be organic, like the web. And it should be that way. We want to reflect the full richness and power of human culture. We just want it to be able to work digitally as well as it should work in the real world. So, the whole point of the trust over IP stack is to enable interoperability across those ecosystems. When you look at it this way, it starts to look much more like the internet. The problem the internet solved was how we were going to move data around between independent local area networks, right? And that, look at the value that unleashed. There are many good reasons. There's a great set of articles that we reference on the Trust Review website, why trust was not put in scope of the original internet protocols. They didn't anticipate the problem, and in many ways it was too hard at that time, especially given the tools we're now putting on it now. But now the internet's grown to the point where we have to solve this problem. So that's how we're going to transition from the Internet of Data to the Internet of Trust. Okay, so if we're going to do that, though, how do we establish trust across those ecosystems? Even if Europe is successful and it sets up its wallets, and Bhutan already has a wallet for every citizen in Bhutan. They're not all deployed yet. It's about a third of the country. And that's only 780,000 people. But Canadian provinces are setting up their digital wallets. Many other countries are looking at it. And of course, all your phones have a digital wallet on it today. It's not an open standard wallet. We hope to get there. Question is, how are we going to do trust across those ecosystems? Most importantly, and this was the question that drove the standards forward when the COVID pandemic hit. How are those credentials going to be interoperable across ecosystems when you have to answer this question, who issued that credential? If your high school friend could issue you a COVID vaccination certificate, that's not going to work, right? You need to know that was issued by an authorized issuer within that ecosystem of that jurisdiction. Turns out the same thing, in many cases, is important for verifiers. First big issue to rise in Europe with digital identity wallets is fake verifiers. It was an attack on the early German digital wallet that Angela Merkel wanted to announce before she finished her term. And the attack was incredibly simple. They had put up posters with QR codes around the country to advise people to go get their digital wallet. And some clever white hat attackers went out and just replaced the QR code on those posters. And the crisis enveloped the German digital wallet ecosystem, and they said, we have to build in verifying the verifier. So that gets to the role of trust registries. So I'm going to talk for a minute now about the bottom layer. This, for trust support, you can see we've listed 3 critical things down there for any system that would want to talk trust over IP. First one is, actually, secure elements has to be either on your phone or on your device. You've got to be able to process the cryptography. So I'm going to skip over that one and just say, second one is the term is verifiable data registry. And that means if you had a DID or any other form of verifiable identifier, the verifier has to be able to check and that the public key or endpoint that it's supposed to be interacting with is the right one. That's the whole problem that DIDs solve. But the last one listed there is verifiable data registries do not solve the problem of authorization. Who is authorized to do what in a digital trust ecosystem? That's the job of a trust registry. This is a larger, little more detailed picture from the Trust Registry Task Force at Trust over IP, which was started when we had to tackle this problem for COVID credentials. And the role of that trust registry for any digital trust ecosystem, it serves as the root of trust for those authorization statements within that ecosystem. So, second prediction. We will end out with as many trust registries, approximately, as we have domain name servers out there on the internet today, right? It's not exactly the same thing, it's solving a different problem, but it needs to scale in a very similar way. Consequence is, just like we needed a protocol for DNS, we need a standard protocol for interacting with trust registries. That's the other major protocol that Trust over IP has been working on. We call it the Trust Registry Query Protocol, and it is similarly at the implementation draft stage. There are implementations going on. That's what I just covered. So if you're interested in that, that is the link to that there. It's also all listed on the deliverables page at the Trust over IP site. All right, now my last point here, finally get to the Global Acceptance Network. Building, quote, DNS for trust is not just a matter of having a protocol, okay? Yes, you have to have that, but there are 3 more steps you have to go through. And we've got a paper that we'll be releasing, I think, next week, the Global Acceptance Network site, that goes into more depth on this stuff. But I'm going to summarize the essential message for you right here. If we say that to build that kind of infrastructure, you have to have the protocol, it's got to be an open standard, it's got to be very widely adopted, then the other three steps are, you got to have open source implementations. Of course, you can have commercial implementations, but any infrastructure standard, if it doesn't have robust open source implementations, it's dead on arrival. But that's not enough. You also, if you want it to work globally, you got to have some governance. For DNS, that was the long process that eventually resulted in ICANN. And I think most of us in this room know what important role, it's not perfect, but the governance role that ICANN plays for the internet. But even that's not enough, because unless you actually bring up in DNS the top level domains, you don't have a domain name system. And of course, over time, that expanded considerably under ICANN's control, and it got more and more robust. Now, why do we need we're going to have this trust registry infrastructure? Well, as I've just explained, it still needs to mature, please engage, but the trust registry query protocol is not that complex. Trust spanning protocol is actually a much, I would say, richer protocol. TRQP is fairly straightforward. But first, we need implementations, open source implementations. They are in progress. Diff, and we want to place one at Open Wallet Foundation. But next, we're going to need governance. And we need something ICANN-like, but this is not governing domain names. This is governing trust registries and trust registry interoperability. That's the role of the Global Acceptance Network, which again, I want to point out, that's a placeholder name. That's a generic name. We're in the 6-month, what we call phase 1, where the early membership is working. One of our tasks is to develop and agree on a trust mark for the network as a whole. And then we need to bring up the first known ecosystems. Now, I want to explain, this is my last points on this presentation. We don't call them top-level anythings. Digital trust is not inherently hierarchical, right? So there are a couple key differences. There's many similarities, but some key differences with domain name infrastructure. And the first one is domain names are designed to be hierarchical. That's why we have top-level domains. And that's why resolution is very efficient, but it is delegated from domain to domain, and domain controller to domain controller. This is very well known for DNS. I didn't even create this graphic. It was so with trust registries, again, trust is not hierarchical. It can be. For instance, over here with these red lines, you might have EU Commission and you have member states going down to municipalities or industries. That would be hierarchical delegation of control over trust registries. But what you see in blue over there is peer-to-peer recognition. We use the term recognition because it's exactly the same term used in diplomacy. One state chooses to recognize another state or not. And when things go downhill between two states, recognition is withdrawn. So the trust registry query protocol enables any trust registry to recognize another one. And so the challenge DeGan is about is, what are the known ecosystems that want to be recognized so that we can begin to have an efficient way to navigate trust registries and enable trust decisions across them. Most of those follow what we call an ecosystem of ecosystems model. That's what our paper will describe when it comes out next week, but I don't have enough time to go into that here today. So as I said, those are the important differences. One more very important one, which is trust needs to work for everyone. And by everyone, we don't mean just governments or just all the organizations out there, but for people. Trust decisions are ultimately made by humans, by individuals, even about working with an organization or a government. So in designing the governance for the Global Acceptance Network, even at this very first stage, which started July 1 and will end by the end of the year is our goal, what we said was, okay, we're going to get a series of organizations who want to see this happen. We call them the GAN founders. And they're going to serve on what we call the Member Advisory Committee. But at the same time, we're going to have a set of individuals. And we call those the GAN ambassadors. And they are not representatives of any organization. They might work for or have an affiliation, but they are there to be the voice of the individual and of civil society to make sure that governance of this trust layer works for everyone. And we made the decision there will be equal numbers. So on the next slide, I'm going to show you 20 GAN founding organizations. And by the way, that number is growing, and I'm here to invite any interested organization who wants to contribute to the GAN. You can not only follow it with me, but also through the GAN website. I can show you in a minute. But for every one of those 20, we appointed a GAN ambassador. This is the first 12. They were announced, I think it was 2.5 weeks ago when we made the announcement that Bhutan was the first national digital identity system to join the GAN as an ecosystem. The other 8 are scheduled to be announced in, I think, 10 days. So we'll have equal number of ambassadors and organizational representatives, and all of that is to help design the initial global nonprofit organization that will go forward, if everything works well, in January. So I will close by making it very clear, you are invited. I'm here. I thank Wenjing and the GOSIM organizing team for inviting me to issue you this invitation. And I thank Angel for doing a great job of moderating all this. Thank you all very much.